Perfect. All right, so you can see the slides, okay? Everything's all good? All right. Brilliant. So welcome. So this is the Schulich Ignite and NASA Space Apps Git workshop. So today we're going to be going through and we're going to be talking about version management in general and specifically using Git and GitHub. So throughout the presentation, basically what we're aiming to do here is we're aiming to explain more broadly what version management is and also why you specifically want to use a program like Git and GitHub to do version management. We're going to get you actually doing a demo with a program called GitHub Desktop and with a GitHub account. And we're also just going to be going over sort of the basics and sort of the conceptual understanding of what Git is, how it works, all of that good stuff. So if anybody's going to be involved for the demo, at this point, it would be a great time to actually sign up for a GitHub account and to download the GitHub Desktop app. Those are going to be the two tools that we're going to actually be using for this demo. So it's going to be much easier if you go ahead and do that. The links for those are just on screen there. So that's github.com/signup, all one word. And then GitHub Desktop is at desktop.github.com. So let's start more broadly with what version management is as a whole. So version management just generally refers to tracking any changes in a project or even just different versions of a project. So for example, here I have Visual Studio Code. For anyone who's done any development work, you might be familiar with it. It's just sort of a text editor and it works really well. And so you can see on the left-hand side here where it says August 21st, there's version 1.6. So obviously there was a version 1.5 before that, so on and so forth. And they also have it organized by the months as well. So you can see the different releases that are there. But also you can see on the right-hand side here that there's actually different versions for different operating systems. So there's a Windows version, there's a Debian version, there's a Fedora version, there's a Mac OS version, and all those different things obviously will be kind of annoying to try and do manually and just have a whole bunch of folders for. And so that's where sort of version management systems come into play and help you to actually keep all of those changes and track all those changes in different versions all together. So let's start with a quick story about sort of an older and maybe not as good approach to doing version management, and then we'll work it to Git from there. So when I was back in high school, I decided that before I did any programming or anything like that, I wanted to do some game modding. And so at the time, the game that I was trying to mod didn't have very good tools. In fact, all the tools were written in Italian, which I don't speak Italian. And contrary to popular belief, Google Translate isn't fantastic at actually translating anything for Italian. So I would often have a lot of crashes and failures in my system, and it would happen pretty often where, you know, I'd get 5 or 6 hours into writing a mod and then it would crash and now all of it's gone. I had to restart from nothing. And so that's where version management comes in. And so the approach that I landed on was basically every night when I had sort of a working version, I would then copy that folder, and then I would go ahead and work on a new version from there. And then I had sort of historical versions of those of that project going back as far as I had been making those copies. So you can see here sort of what that looked like, just a whole bunch of folders all together with all these different versions of the project, so that if it broke again or when it broke again, I'd be able to take a step back and be able to just start from fresh from an older version. And so there's a couple of different advantages to version management. One of them is that you can actually have different versions. So a lot of the times with projects like operating systems, so in the Linux community, this is pretty common where you'll have like a performance version and then you have like a flexible version. And the idea is that basically you have version management that's tracking both of these two. And then you can have people who are interested in the performance version but don't necessarily want to do any hacking to their system can then download the performance version. And people who want that full flexibility have the flexible version, and it all works out pretty well. But the main purpose of version management and sort of the main saving grace for it and why it's used so often is being able to revert back to different versions in multiple different situations. For example, having older versions sometimes that work better for older systems. People who have long-running software projects, for example, they might have versions that were compatible with Windows XP and now are no longer compatible with Windows XP. And if for some reason you're still using Windows XP, which you probably shouldn't, but if you are, then you should be able to go back and download an older version so that you can actually use it. Additionally, things like if new versions break functionality, sometimes if you're writing code, you may decide that, you know, this feature isn't very useful. It takes a lot of effort to maintain. So we're just going to remove this piece of functionality because nobody uses it anyways. Turns out somebody uses it. Okay, well, now they can go back, grab that old functionality, go from there. And sometimes people just prefer how old systems operate. There's a lot of people who I know who still use Photoshop CS3. For some reason, they like the terrible layout and design for it. that's their own choice. If they want to be wrong, then they can go ahead and do that. And version management gives you the flexibility to go back and use those older versions themselves. And then at the bottom here, I just have different Python releases. Just as an example, Python 2.7, when they switched over from 2.7 to version 3, they've removed and changed a lot of the syntax, and it broke a lot of stuff. So being able to go back, download the old versions of Python to be able to use those old pieces of code is just really good, because otherwise, essentially all of that code is just scrapped. macOS itself, for example, uses Python 2.7 a whole lot. And yeah, so version management generally comes in a lot of different shapes and sizes, from different naming schemes, like, for example, different dates that I had in my story, or you might have things like iOS 7, 8, 9, 10, etc. You have Python, point releases, what they're constantly called, so 2.4, 2.5, 2.6, etc. Or even just give them code names. Android, when it used to be fun, used to have good code names. They used to have, Kit Kat, Lollipop, Marshmallow, Nougat, Oreo Pie, all these different things, cool nicknames. Now they just have version numbers, which is kind of boring, but there's a whole bunch of different ways of doing naming systems, and sometimes they can be really helpful for telling people information about your system and sort of where it's at. And there's a ton of different software to do version management. So Git, which is the most important, it's the most commonly used, and it's the one that we're going to be using today, is very handy for doing development work. SVN and Mercurial are some older ones that you may hear about. SVN stands for Subversion, so you may hear about that at some point. Perforce is often used in the games industry because it has some specific game features built into it. But oftentimes people just tend to use Git for sort of everything because it's just so versatile. But there's other versions of version management that you've probably already used that are a little bit less obvious. So Google Docs, Google Sheets, OneDrive, for example, they obviously track changes. That's how they know when things have been changed by different users. And so that's actually an example of version management itself. You can also actually go into Google Docs, and there's a version management tab. I think it's called the History tab, and you can actually go back to previous versions of it as well. So you've probably likely already used version management. And for me personally, I've had it save me a couple of times already on Google Docs itself. So let's talk about some of the issues with my approach and where something like Git would actually come in. So obviously copying files over constantly is not too bad when you have a small project, but when you have a larger project, it starts taking up a lot of space. If you have a lot of images and stuff like that in your project, for example, constantly copying folders takes up a ton of space. Likewise, tracking what files actually changed is really hard manually. What I ended up doing towards the end of my work was I started having like a text file where I would just manually write things out and say what I changed. But it's not necessarily the best system at all, because I don't actually know where those changes have happened in the code or wherever the changes are actually happening themselves. Likewise, because of my system, the version numbers really only meant anything to me because it didn't actually indicate any like specific changes. They were just sort of dates, so it's not very useful. And there was no messages really to go along with it or anything like that, or any way of tracking what those changes actually meant. If somebody wanted to help me, they'd have to download all the folders, like I said, because it takes up a lot of space. If you want to go back and forth, you got to download all these files, make sure you have all the files ready to go to be able to switch back and forth between them, which is not very handy. And if you want to actually switch between them, you got to copy them across, move them across, do all the file management yourself. It's not fantastic. And obviously the biggest issue with my approach was using Google Translate instead of actually finding somebody who spoke Italian. This isn't fixed by software management, but just something to keep in mind, find somebody who speaks Italian. Duolingo doesn't help. Google Translate doesn't help. Your code will crash constantly. If you can, just use tools in English, much easier. And so this is where Git actually comes in. So Git is a much smarter way of doing the version management itself. It's very easy to set back and forth between different versions of the code. So if you even just want to go back to just see what those old versions of the code look like, for example, that's much easier to do with Git instead of pouring through, a bunch of source files and trying to find the files and whatever. It's much easier to do with Git because Git actually just tracks the changes that happen. So it just sort of keeps a record of this file was changed here. This is where and how it was changed relative to where you're currently at. And so because of that, it also uses up a lot less space, like a lot less space. And on top of that, it's obligatory when you're using Git to add a message when you're making these changes themselves. So when you're saying, okay, this is the change that I made, you have to actually add a little message and a little description. And that is super handy when you come back, a year from now and you want to see that you made a change. You may not remember that, oh, yes, when I made that change to the battle that happened in the game, that was actually on April 24th. You might not remember that, but if you have a message in that says, change to battle, whatever, it's much easier for you to go back and actually see those changes with the messages beside them and have it be much more clear exactly what actually happened. And on top of that, Git itself is integrated with a ton of development tools. And so it's really easy to collaborate and use tools like GitHub, for example. It's also easy to do a whole bunch of other fancier things, like some server management stuff often uses Git to do changes. And there's just a ton of tooling out there that's available that integrates really well with Git and makes it really easy to use. So let's actually talk about what Git looks like in practice and the workflow that Git involves. So let's just say that you're working on a project and you want to try and make some changes. So first you need to create or clone the repo. So repo here, that's just a short form for the word repository. This is just the name that's given to basically just the folder. The way that Git works is there's essentially inside of, it tracks your files on like a folder by folder basis. So you have sort of a parent folder and then all the changes to any of the files and folders inside there are tracked. And so repo or repository is just another name for that folder that actually is being tracked by GitHub and all of its contents that are inside of it. So you either need to create that locally or you need to create it in the cloud on a service like GitHub and then pull it down locally to be able to actually use it. And so, yeah, so you just need to create or clone that repo. Obviously, you need something to actually start working from. From there, we add whatever changes that we're intending to make. So that can include, creating files, editing files, deleting files, all of that good stuff. And we want to actually add them to what's called a staging area. So essentially, once we've added these files to that staging area, we're just saying, okay, these are the changes that we actually want to do. And then from there, we have to actually commit to those changes. And then what that basically says that like, okay, these changes are good. These are the changes that we want to make. And it also means that you can, like I said, with the commit is where you actually add the message. So for example, let's say you make a change to 10 files and 3 of those files, the changes in them were adding some specific thing. You may add those 3 files to a commit, and then you may add the others to another commit, stuff like that. That's sort of the flexibility that Git gives you. But basically add everything up, commit it to your local, and then now on your folder itself or in your repository, you now have those changes saved, and that's sort of like a save position you can sort of think about. Each of those commits is a way that you can sort of say, okay, this is a point in time that I have, and now I can go back to it later on, stuff like that. And then obviously, because in this case, we're using a cloud service like GitHub or a remote service is what they're typically called, we then have to actually push those changes. So Git works offline and online. So committing is good enough to have those changes show up on your local machine, but then you have to actually push those changes for them to show up on GitHub or any other service that you're using. And conversely, if somebody else has pushed up their code, you will then have to pull that code down to be able to see those changes yourself. And then essentially for the rest of your development process, it's just steps 2 to 4. Make your changes, commit them, push them, you're good to go. And in that add step, if there's changes that you make that, for example, this thing doesn't work, I just want to scrap it, you can just say git restore and it will take it back to it'll just wipe those changes away and you don't have to commit those changes at all. So Git's really powerful for allowing you to do stuff like that and have the flexibility to, even just within a single commit, be able to sort of step back and forth between the changes that you make. So let's get more specific with this and break this down into actual steps. So step 1, this is often called GIT INIT. This is just what it's called typically in the command line. And so this is just broadly what refers to creating a new repository and getting it on your local machine. So whether that be creating it on your machine and then sending it to the cloud so that it shows up on the cloud, or creating it from the cloud and then cloning it down. Either of those two are often just called the GIT INIT step. And that's just basically getting the repository or the files and folders on your machine itself so that you can start working on them. From there, like I said, you just add your changes. So you go ahead, add those changes to the staging files. Like I said, that is the staging area rather. So like I said, that is creating new files, editing any existing files, deleting any files. Once we add those files, you can also always remove those files. If you're, say, not happy with those changes, you made some changes and then you made some more, and before you commit them, you want to pull a file that you've changed because you're not sure whether or not you want to add it yet. You can always do that. That add step just gives sort of an extra, make sure that we have everything in order, and then we go ahead and actually commit those changes. And once we commit those changes, now we have that sort of save point made so that we can always come back to it, reference back to it later on. And then because we're using something up in the cloud, we got to push it up to the cloud. So then we go ahead and push our commits up to the cloud so that everybody else can see them and everybody else can use them, and just go from there. So now we have the demo time. So I'm just going to quickly do that, minimize that. All right. So for the demo, what are we going to do? So we're going to create a repo on GitHub. Like I said, you can create it locally and then you can put it on GitHub afterwards. But I personally just prefer for my workflow to just keep everything on GitHub and then create it there and then clone it down. And then from there, we're going to make some changes. And then after we make those changes, we're going to add and commit them. And then we're going to push those changes to GitHub so that we can see them. So let's get started with Git init. So if you signed up for a GitHub account before, I'm going to quickly switch the screen share over to my other monitors. Give me 1 second here. Screen 2. There we go. All right. So if you have already signed up for the GitHub account, this stuff will be pretty easy. Just log in. It'll look something like this. And basically what you're going to do from here is in the top right-hand corner, there's a little plus. You're just going to go ahead, hit that little plus, and then just hit new repository. Once we're in here, we go ahead and we have to actually create our repository and set everything up. So we have to give it a name. You can give it whatever name you want. You can also click this little green thing here and it'll give it a name. I'm just going to give it a random name because I have a whole bunch of projects already existing on my GitHub account. So I just want to make sure it doesn't clash. From there, you can give it a description. So this is the demo for Schulich, NASA, intro to Git. And from there, you can then choose public or private. It basically says what it does on the tin. It's either public and everybody can see it, everybody can clone it, everybody can do whatever they want with your code, or alternatively, you can make it private and then you have to individually give people access to it. I know that people who might be watching this are probably doing hackathons. I will be honest with you, probably easier to go public for most of your stuff, unless you have something that's like really sensitive that needs to be held privately. Probably easier to go public. It's going to make it just easier for you and everybody else to use. Trust me on that one. And then on top of that, there's some extra stuff here. So there's add a README file, which I'm going to check off, and I'll explain what that does later. And then there's other things like git ignore and license. If you're interested, there's a little learn more button. You can read about those. We don't have time to get into them, but if you're interested, you can take a look. Basically, git ignore files just say, you know, I don't want these certain files to be tracked. And license just says, what can people do with your code? Once we've done all of that, we're just going to go ahead and hit create repository. So back here on the slides. Basically, that's just what this slide is explaining. So you just want to enter a name, enter a description, set public or private. And then in our case, we want to make sure to add a README and then hit just create repository. Perfect. So now we need to actually clone down the files. So like I said, because that's been created and that was part of the Git init, since we created them remotely, we now need to have them locally. So to do that, we're going to use GitHub Desktop. So I'll just go ahead and open up GitHub Desktop for me. Once you set it up, it should ask you to actually sign in with your GitHub account, which makes this a lot easier because once you've actually signed in with your account, all of your stuff will show up on the left-hand side or on the right-hand side here rather. Or you can just hit clone repository from the internet, or up here, you can just hit clone repository. From there, we can search for what we were looking for. So in this case, that was ideal computing machine. So we can click there to set that up. If that's not showing up for you, you can also click the little refresh button so that it actually shows up for you. If you created it recently, then it might not show up right away. So you just need to click that refresh until it shows up. And then from there, you can pick where you want to save it. So in my case, I just have a folder on the desktop called demo folder, and I'm just saying I want to save it under the ideal-computing-machine folder. Now, if I go ahead and hit clone, it'll clone a whole bunch of stuff down for me. Do a bunch of stuff in the background. And if I just go ahead and open up here where it says demo folder, you can see we now have a folder in there called ideal computing machine. If you have see hidden folders checked, you'll see this .git. That's how you know that it's a GitHub repo and not just a regular folder. But we can see we have our README file. So if I go back to GitHub, for example, you can see this is sort of our view of that same folder. It looks pretty much exactly the same, except for it's on the internet. So now that we have all of that stuff cloned down, we want to go into the next step, which is actually making and adding your changes. So if we come back to the folder itself, and I just go ahead and I click on like the README file, for example. So I'm just going to be using an editor just called Typora, but you can use anything. You can just use Notepad. You can use any text editor. And we're just going to add some changes. So this is a change we are making Okay, so basically, so we've added these last little lines here, and what this actually looks like in Markdown is just this. So that's basically what we've actually added to the file itself. Now, if we come over to GitHub Desktop again, we can actually see those changes. So inside our folder, when we click on the file that we've changed, we can actually see those changes. So the green and the pluses actually show you exactly what's been added, and then red and minuses will show you what's been removed. So I'll just quickly show that on the presentation. So if you remove lines, for example, here, it'll show up with the red line. And if you add stuff, it'll be green, and it'll have the little pluses. And so what we're going to want to do is just check off the files that we want to add. So if I didn't want to add the README to my next commit, I could just uncheck it here and then check some other files and go from there. I obviously do want to add it to my commit, so I can go ahead and hit this little plus. If you want to just add everything, you click the little plus up here, and that'll do it for you. So next, we want to actually commit those changes. So now that we've made the changes, we've added the changes, we now need to actually commit to them. So basically for this, all that we need to do is just add in a little description and a little message, and then we can commit them. So if we look here, for example, so this is what we currently have, right? I can go ahead and I can say added text. I can say, I can put in a long description. So this is where more details would go. More details would go here. Obviously, we only change some text, so we don't need to add anything extra, but we can add it there if we want to. And then we can go ahead and hit commit. And there we go. Now, so this change has actually been saved locally in our commit. So if we click on the history tab, for example, we can actually see that change right here. So we can actually see, add some extra text, and we can actually look at that commit that's been made here. But even if we refresh here, we actually don't see the changes yet. And so that's where the last step comes in, which is when you're using GitHub, you need to make sure that you actually push those changes themselves to the repo. So we kind of click in the top here where it says push origin. Origin just basically means the remote or GitHub itself. And so we can either click there to push it. We can either click here to push it. There's a lot of different places that you can go to push it, but we can just make sure we just go ahead and hit push origin. And now if we come back to our GitHub repo and we refresh, we can see here it says 2 commits. It has the actual message that was included with our commit when we made the change, along with, it shows up here with our message and our little description. And the actual files themselves have now been changed. The only reason I changed the README is so that you can actually see the change directly right here for you. And if you want to go back in that history, you can do it directly on here. And you can see, we added some extra text here. And let's say I wanted to see what the files look like back in the good old days when I first committed it. I can click on that first commit that I made, and I can go ahead and I can hit browse files, for example, and I can see exactly what the files look like back then. Okay. So that's the very basics of Git. Essentially, you could probably get away with writing 90% of your projects just by doing all the stuff that we showed you right there. You'll probably be able to get away with doing that for most of any personal projects that you're working on, especially if you're working by yourself. But there are some extra features that are pretty important, especially if you're going to be working with a group, that we just want to go over to make sure that you're aware of them and that you can look into them a little bit further and how to use them a little bit. And so the first one that's super handy with Git is branches. So if you remember earlier, I talked about being able to have multiple different versions of software, and this is where branches comes in. So essentially you can see here, so like this main branch, this is sort of where we're working off right now. And this is basically the changes that exist that are sort of like our like main piece of code, essentially. But from there, we can have different branches, and people do have different methods of using branches in different ways for different projects. So for example, I can actually show you one example of this from some of my own work. Let me just quickly scroll down. So this is a project that I have, for example. This is called EasyCV, and basically right now it's currently on version 0.2.2. But if we go into the branch list, version 0.3 is actively being worked on, and I can work on it, and it's 5 commits ahead of the main branch. Sometimes the main branch is called master. If you use old versions of Git, then it will be called master instead of main. And essentially, I can work on version 3.0 without harming any of the code that currently is being used by other people. And so that's one example of being able to use Git branches. Some other people do it for individual sort of features. So in this case, we have an example where someone has made a branch called add to-do list. So maybe this is sort of like a like personal management app where you like manage your fitness and stuff like that. And then maybe you want to also add a to-do list. then you can create an add to-do list branch and write all your code in there. And there's a ton of different reasons why you'd want to do this. One of the main ones being that if you're worried that you're going to break anything, if you break it in a side branch, it doesn't matter, because as long as you either fix it or if you want to even throw it away, it doesn't matter. It's separate. It's all completely separated and sort of sectioned off by itself. So whatever goes wrong in that branch doesn't really matter. Your main branch is still safe. And so we can actually go through, and I will show you quickly, just because we have the time, how to make a branch if you really wanted to. So inside of GitHub Desktop, the easiest way to make a branch is right here in the top. There's a thing that says current branch, and we can just go ahead and we can add a new branch. So in this case, I would recommend, if you're going to have branches and you're going to try and be organized like this, try and give them a name that actually matters. In this case, this isn't a real project, so I don't really have any good names that I can use. So I'm just going to say making some changes. And so now you can see here in the top, it says what current branch that we're on. So we're currently on making some changes. And let's just say I come into here and I'll open this with Visual Studio Code, for example. And maybe we'll add another file and we'll call it new file.markdown. Text in here. And then we'll just say changes. So now we've added some text. We added a new file here, and we've made some changes in the main README. So now if we go back to GitHub, or to GitHub Desktop rather, we can see that we've made these changes. We can say added important changes with our description that we would normally put in there. The description is optional, but the message isn't. So just make sure that you include the message. And so let's say that we commit this to the branch. There we go. So it's been committed to the branch. Now we can actually see this in real time. So here's what the files currently look like, because we're on the making some changes branch. We can actually go back to the main branch, for example, just like that. And you'll see that file that we added disappears because now we're back on the main branch. And if we go into the history, we only have those initial changes that we made. And then if we switch back to that making some changes branch, we can see that new file appears. And in the history, we can see our new changes. And we can also see that our changes have not yet been published. So if we currently go right here and we refresh, we actually only see one branch available. And that's because the same way with pushing and doing all of your commits, GitHub doesn't know that you created a branch since Git works locally. So currently we only have a branch that's available locally. So what we're going to do here is we're going to push both our commits that we've made on this branch and the branch itself to GitHub so that it shows up. So we'll go ahead and hit publish. And you can see this actually shows up here. And if I refresh now, there's now two branches. So here's our main branch here. And I can switch over to that making some changes branch where we can see all the changes that have actually happened. Now, the next question is, okay, well, what happens if we make our feature and we want to actually bring it into the main branch so that everyone can see it? Well, that's where merging comes in. So merging just allows you to combine two branches together into one. So in the example here, this is where the add to-do list branch that's sort of made the changes here, where you have these different commits. The little red dots indicate commits. Make the commits, and then we add them back into the main branch itself. What does that look like? Well, there's a way to do it locally, but most of the time, what most people tend to do is if you just locally switch back to the main branch, and then inside GitHub, you do what's called a pull request. And so, like I was saying, whenever you make changes, for you to know about those changes, because your Git works locally and remotely, you'll have to actually pull those changes down from GitHub so that your local version is aware of those changes. And so what we can do here is we can create what's called a pull request. And basically what this means is that we are going to ask the main branch to pull our code from our other branch into itself. And so this is also how you can have different code changes that you make, and you can give them to other people, for example. So if you're working on like a project, like, for example, maybe like EasyCV or some other open source project, you can actually have people you can make these pull requests and have people actually pull that information from your branch to theirs so that your code shows up in their project. So I won't get into the details of like all the different stuff that you can add in here, but basically we'll just go ahead and we'll hit create pull request. And in here is all the information. So we changed 2 files. So we removed some stuff and made some changes in the README file. And in our new file, we added some stuff. And we can see our different commits. So if we had multiple commits, they would all show up here. And then we can also add comments and we can assign people and do a whole bunch of fancy stuff. That's all just GitHub side stuff. So you can go ahead and do that. You can look into that yourself. But what we can do then is we can say merge pull requests. And so when we do that, we have to sign off with our information and all that sort of stuff. And so we can just say then confirm merge. And now since it's been merged, we can just delete this old branch. And if we go back to our code, we can now see inside of our main branch, which is what we're on here, we now have all of the changes that we've made. So essentially what we've done there is we created a branch, pushed that branch up to GitHub, and then on GitHub, we've asked our main branch to then pull those changes down into the main branch, and now it's there, and we've deleted the old branch. So if we come back to our GitHub Desktop, for example, since we're on that main branch itself, and we've made those changes remotely, we now have to make sure that we can click up here where it says fetch origin to pull those changes down so that the changes that we've made will show up. So we hit pull origin, pull those changes down, and now our main branch matches the branch that we have on GitHub. Perfect. And now the last topic that we want to get into is Git using the command line. So we've shown you how to do all this stuff using GitHub Desktop. And the reason that we did that is that it's just common across all systems. It's much easier to set up than regular Git. But most people commonly use Git at the command line just because it tends to be a little bit faster and a little bit easier. And so we're going to show you how to do that as well. So Git on the command line. So for making new repositories, we'll just go through each of the same steps that we've talked about before. So inits, commits, all that stuff using the command line. So first of all, git init. Like I said before, you can initialize stuff locally. So if you want to, for example, if we come into this demo folder again, and we open up a command line, we can, for example, do git init, maybe just say project name. And it will create a project for us in here that's being tracked by Git. This is called project name. And then from there, we can hook it up using this command below that just says git remote at origin your URL. This way it works. We've added in here just so that you're aware of it. But I personally pretty much always create my projects on GitHub and then clone them down. It just tends to be much easier. There's no issues. You can have issues like this if you accidentally have like the same name and stuff like that. And GitHub just checks that stuff for you before you actually have it happen. If you want to use other things other than GitHub as well, they will also work. But just any of those online services tend to be a little bit easier to use for initializing your project. So instead, what I tend to do is I recommend creating it and then using git clone instead. So if I go, for example, and I come back up here and I initialize a repository again, we'll just call it whatever this is. Let me go ahead and add the README. Right, so here we go, we have our stuff here. All you have to do once you've created it is just click this URL at the top here, which should be your username and then whatever your repository name was there. And then at the command line, we just have to type git clone, and then we just paste that URL. We go ahead and do that. And it does the exact same thing. So that's personally how I tend to do it. That tends to be how I recommend other people do it as well, just because it tends to be a little bit easier. That git remote command is a little bit finicky, so I would just highly recommend doing it through git clone instead, personally. Now, once you've made those changes, we'll go through and we'll just do the same steps. So if we go ahead and go into our new project here and we make some changes, we say, for example, this is a change. Go ahead and save it. Now we can check the status currently. So if we go ahead and actually enter that folder, we can now check the status. So we can go git status and we can see, okay, we've added some files here. Or we've modified some files, but because they're red, we haven't actually added them. So we can see it says here, these are not staged yet for commit. So they're not in our staging area. So we can say, okay, so we need to stage them. So we can go git add, and then we can either type in the individual file names. So we can type in readme.md, for example, or we can just hit dot to add all of our changes. And then from there, once we've added our changes, we can go ahead and we can hit git commit -m and then our messages. So git commit -m and then whatever our message is. So in this case, it would be we made changes to README. And then we can go ahead and hit enter. And we can see we have one file changed on the main branch, and it says one file, 7 insertions with 1 deletion. Right. And then we just go ahead and so this has the full command here, but honestly, what you can do is you can just type git push. And what'll happen is that because we cloned it, we don't have to worry about git push origin, all of that stuff. We can just hit git push. Now for branching on the command line, it's also just sort of the same thing. So we just go ahead and we type, for example, git branch. We then have an extra step that normally we don't need to do on the GitHub desktop, which is checking it out. So we go git checkout, new branch. So we say that we want to go and switch to that new branch. And then now if we hit git status, it'll tell us which branch we're on and that there's nothing to be changed. I'll actually make this a little bit bigger so that you guys can read this a little bit easier. Hello. There we go. A little bit easier to read. So now we're on the new branch with nothing to commit yet. We can go ahead and we can make some more changes. So here are some. Go ahead and save that. Then if we type git status again, we can see, okay, we made some changes. So we can just say git commit -m, change readme. Sorry, we have to add it first. Git add dot and then git commit -m. And now we've added our changes to that branch. We can go ahead and we'll type in git push. And it'll give us this message and it'll say, oh, this doesn't exist. The branch doesn't actually exist. And so if we actually go to this file, you can see we have our changes, but our branch doesn't exist. So that same step that we had before, we had to hit publish branch. Basically, that's just what this command right here does. It just says, okay, we got to publish the command, or publish the branch rather. So we just copy that, paste it, hit go. And we have our new branch set up from the command line. And then if you ever want to change back, just do git checkout and then either main or master, depending on which one is the name of the branch. It's your primary branch. And then that's it. That is how you use GitHub, or Git and GitHub at the command line. And I just want to thank everyone for coming. So you can check out our social medias at Schulich Ignite on Instagram and on Facebook at facebook.com/SchulichIgnite. As well, you can also check out our website at schulichignite.com. I helped set that one up, and that one also does use Git in some pretty interesting ways. So I definitely recommend checking that out if you want to see some of our other resources that we have available. And that's basically everything. So if anybody has any questions, I can go ahead and take them now.
Thanks, Kieran. That was great. You can maybe stop the recording now.
Yeah, I'm just trying to.